The function C for concatenate, in addition to combining single elements together into a vector, it can also be used to join two vectors together. So if I have a variable x that is 1, 2, 3, it's a vector of numbers 1, 2, 3, and another variable y that's a vector of the numbers 10, 11, 12. As shown here, I can even print them individually, x and y. Then if I calculate a new vector, z, which is c of x comma y, so now the arguments to the c function were names of variables instead of individual discrete numbers. Z is going to be x concatenated with y, 1, 2, 3, 10, 11, 12. Other useful functions to keep in mind. So I'm going to initialize x with the integers from 10 through 30, just for the sake of example. There's x, I've printed it to the console. I used the colon because remember the colon is an operator that it's sort of like a function that takes two arguments, here 10 and 30 that come before and after it, and it returns a vector of integers starting with 10 and ending with 30. And one thing that I can do is ask for the length of x. The length of a vector is the number of elements in it. So this one has 21 elements in it because there are 21 integers between 10 and 30 inclusive. The sum of x is going to add together all of the elements. So that's 420. The mean of x calculates the arithmetic mean of the values in x. So that's 20 in this case. Var of x, VAR for variance, calculates the sample variance of x as though it was a vector representing a sample from some larger population. SD of x calculates the sample standard deviation, which is just the square root of the sample variance. Min of x is 10, that's the smallest value in x. Max of x is 30, that's the largest value. Those stand for minimum and maximum. And median of x returns 20, in this case the same as the mean because the median is also 20 for the example that I gave. So far I've been working with examples of a variable named x that is a numeric vector, a vector where all elements are numbers. It's also permissible to have a vector of strings. This can be useful for a lot of data applications. So here is an example. I created a vector religion that is the result of a call to the concatenate function C with 5 arguments. The first argument is the string Catholic, which I've specified is a string by surrounding it with quotation marks. So this data element is actually just the letters CATHOLIC. The quotation marks are part of the code that I use to specify that those letters should be taken as the component parts of a string rather than the name of something that R should look for. If I didn't have quotation marks, of course, R would look for a variable called Catholic, just like it has done every other time I've used a word in my code before. So the elements here are Catholic, Jewish, Buddhist, Baha'i, and Muslim. And notice that Baha'i includes a single quotation mark, or an apostrophe really, in the string itself. That's acceptable because I used double and not single quotation marks for the string indicator. So R knew that this apostrophe or single quotation mark was not the end of the string, but actually part of the string. It was waiting for another double quote before it would consider the string over. If I needed to include a double quote in a string, then I could use single quotes to indicate the beginning and end of it so that R, again, would not end the string as soon as it saw the double quote. If you need to include both single and double quotes in a string, consult with me. A vector, by definition, contains elements that share a type. So you cannot have a vector with some numbers and some strings. If I try by concatenating 1 and then 2 and then apple, the vector that the concatenate function creates is actually quote 1, quote 2, and quote apple. In other words, this is not the number 1 and the number 2 in the string apple. It's the string of the numeral 1 and then the string of the numeral 2, and then the string apple. It automatically converted those numbers to strings so that they would match the type this vector had to have in order to be valid, because I attempted to include the element apple in the vector. As you've noticed by now, the comment character in R is the pound sign or number sign. This character that I've just typed at the console. I recommend using it extensively. What this character does is it tells R not to execute the rest of the line after that character. So if I type mean of x plus standard deviation of x, and then the pound sign or the number sign, followed by the clarification compute one standard deviation above the mean, then R just gives me the number 26.20484, right? It has calculated the mean of x and calculated the standard deviation of x and added them together exactly as instructed, and it did not give me any errors about these words being unrecognized commands because they all came after the pound sign, the number sign, the comment character. You should use that in order to explain your code, generally speaking. You can also use it in order to prevent a line of code from being run when you're running a larger group of lines if you don't want a particular one to be run. If something in R does not work as you expect, or you want to know more about how it works or why it works the way it does, look at the documentation for that thing. The documentation of a function can be accessed by using the question mark or the help function. So let's look at an example. I'm going to type question mark rep at the console. I'm going to execute that line of code, and that brings me to a web browser, which shows me the documentation for the rep function, REP, which is a handy function available in base R that just repeats something, some number of times or for some length. And we will use some examples of that next time. But I could read all about it. And when I'm looking at a help page like this, one thing that I will look at is the description of the function, the first part. It gives a general idea of what the function's trying to do. Under usage, I might see different variations of the function, and I might also see different options for its arguments. This is also where I would usually look to see default values of the arguments, although in this case, that's not as helpful. We'll see other documentation pages as well later. And down here in the arguments section, I'll see details about what values I can provide for each of the arguments and how they might be useful to me. Another place I often like to look is the value section of the documentation. That will tell me what kind of output this function is going to give me, the type of value it's going to return. In this case, an object of the same type as x, which if you recall from up here, is the first argument to the rep function. So if I call the rep function with 1 as its first argument and 10 as the second argument, which is the number of times it'll be repeated, I get a vector of 10 ones. And it's a numeric vector because 1 was a numeric value. I can also view the documentation for that function by calling the help function. The question mark is just shorthand for the help function. So if I run this line of code, I get exactly the same web page that I got by calling the question mark version of the function. So one example that I already showed you is rep 1, 10, which repeats the 1 10 times. I could do things like plug the result of a rep function in another function. So here I'm going to repeat 1 10 times and make that the first argument to the C function for concatenate, and then rep 0 10 times and make that the second argument to the C function for concatenate. And now I get a vector of length 20 with 10 ones and 10 zeros. I'm going to do a lot of that in this workshop, where I will call one function and its arguments will be calls to other functions. Remember the comma just separates the arguments to a function. This line of code that repeats 1 10 times and then 0 10 times will give the same result as this other line of code that uses another argument to the rep function instead. The first argument is just the concatenation of 1 and 0, a vector of length 2. But the second argument says each equals 10. So instead of repeating 1 0 1 0 1 0 for a total of 10 times, it will repeat each element of 1 0 10 times. So 10 ones followed by 10 zeros. In this workshop, I'm using a script file over here on the right-hand side of the screen, separate from the command line, the console over here on the left side of the screen, in order to automatically run many lines of code. I'll be continuing to do that for the rest of this workshop with different script files that I've already shared with you. Files like this are typically saved using the .r extension. They're just text files. All they do is contain plain text, but that text is a set of instructions that can be executed in the R programming language. And so in order to signal that to software that might be able to read those text files or other humans who might open them, we use the .r extension to communicate that that file contains R code. That concludes what I think of as the first unit of the R workshop, the unit that provides a very basic introduction to programming in R. Next, we'll talk about statistical functions in R, and that will probably take a couple of sessions, but I think of that as Unit 2, and then Unit 3 will be more sophisticated programming that I still think of as kind of essential introduction in order to understand how to tell R what to do.